Hello and welcome back. If you follow the channel, you know that we restored an Apollo guidance computer, or AGC as it is known, to full functionality. We even flew some landings with it, complete with the original Apollo 11 software running on it. In this iconic photo, the AGC is proudly presented with its display keyboard interface, or DSKY for short. The DSKY was how the astronauts communicated with the computer. It was sitting prominently at the center of the control panel and was very heavily used during missions. In fact, there were not one but two DSKYs in the command module. One on the main panel and another one in the lower bay next to the telescope and sextant, called the navigation DSKY. There was also one in the LEM, the one that famously displayed the 1202 error during the Apollo 11 landing. You can see it here in between Neil Armstrong and Buzz Aldrin during training. We admit to having had a long love affair with the DSKY. During our 2019 restoration, Carl built a gorgeous replica that we connected to our now functional guidance computer. It was quite convincing, and we even reproduced the famous MIT picture using our restored AGC and Carl's DSKY. But Carl had to use one practical shortcut. He used LEDs in the display, a technology that was many years in the future at the time of Apollo. You see, NASA had developed a very unique and advanced solution for the DSKY, a solid-state electroluminescent display, which we had only seen in some low-quality footage. We always dreamed of seeing the real screen in person one day. We came a big step closer to our dream when friend and science genius Ben Krasnow made a replica screen for us, building electroluminescent panels from scratch in his garage lab. He donated the screen to us after he was done, and that gave us our first look at a real electroluminescent display glow. But the story gets even better. A few years later, in 2021, friend and collector Marcel brought us a genuine Apollo DSKY display that had been sold at auction. It was a real Apollo flight spare that had waited in vain for man's return to the moon for the better of 50 years. Carl managed to reconstruct enough of the electronics to make it work, and lo and behold, it lit up perfectly. We were amazed by the result. Such a crisp, cold to the touch, high contrast screen. You'd think it was an iPhone screen in 1968. That was the closest thing to experiencing a real DSKY we thought we'd ever have. But imagine our surprise when Marcel recently showed up in the lab one day carrying a mysterious large case. Could it be?
Piece of Apollo history. I've seen various forms of it, but this is the DSKY. Back and front.
It's a DSKY.
Oh my, there's an issue on this one. But that's okay, we can fix it.
We have the technology.
This one was from MIT?
Yes, this is from an MIT simulator.
And oh dang, it's in the shadow. We have, yes, thank you. It had a little accident.
So it was well used, especially some of the buttons here. You can tell what the entrance code probably was. And one thing we can get out of this is, since it is broken, you can see a little bit of the manufacturing aspects of how that display actually was created. Some of the contacts in there.
That's too bad people break this kind of stuff. But I guess we have an extra screen for it.
I think we do. And there was one thing on the back of this to note. Right here, there's a little dent, and it looks like it might have actually pierced the shell. So I suspect the nitrogen might have leaked out, but that's okay. We're going to be probably opening this anyway.
Yeah. I mean, it's pretty easy to to check. I think that's just like a regular trader valve.
Yeah.
Yeah.
No pressure.
It's gone.
Okay.
Well, that would be cool. Oh, and then we are stuck with another one of these connectors, our nemesis.
Yep, exact same connector.
The Deutsch high density connector. Well, I bought more pins, so.
Yep.
Ray 39 up on the bench.
Okay, well, pretty neat.
Definitely looks like some of the, like the 2 and 3 were replaced at some point. The keycaps.
Yep. Yeah, I guess so. We'll get to think if we want to do a full restoration or just kind of examine it as is. I think we'll probably do a display swap, and I'm hoping, we're not entirely sure, that all the proper guts inside here are there. It's
Yep.
not just full of sand.
Very curious to see that. We've never actually seen the modules inside a DSKY before.
So we'll.
And it'll be interesting to see how many of the leaf springs on the keys are intact and how many are not.
Still, it's pretty good
Okay.
travel. There's one or two. I think they were a little sticky, but this one's a little sticky.
Yeah,
And
it's
we
still
know where
clicking
this
though.
is from, right?
That one might be broken.
It looks like it was pretty heavily used.
Yeah.
With all the letters rubbed off and stuff.
The documentation that I have for this one says it was sent to MIT for simulator use. So who knows exactly how much they used it and where, but
They had only 2 simulators, right? They had the CM and LM simulator, or did you had some other place where they had DSKYs?
I don't know. It's a good question.
Here's the best picture of the MIT command module simulator I could find. You can clearly see that the 2 and 3 keys are very damaged, and these are the ones that appear to have been changed in our DSKY. Is this ours? It's hard to tell, as I don't see any other obvious details that match. Your guess is as good as ours. By the way, in case you're wondering, here are the main areas of the DSKY. On the left, there are a bunch of caution and warning lights. Which exact ones are on there vary from CM to LEM and did evolve with the development program. At the bottom is the keypad. The large buttons with large throw were made so they could be operated safely with astronaut gloves on. On the right is the display area. The first number at the top right is the program you are currently running. Program 63 in the LEM would be the beginning of the landing bird, for example. When you do nothing, you run program P00, lovingly called Poo. Next are the verb and nouns, the directives you give to the program. Below that, you'll find 3 lines of data that you can read or use as entries. What numbers are displayed there depend on which verb and noun you are currently using. There could be very different things: roll, pitch and yaw angles, or altitude and speed, time remaining in your burn, etc. Even your 1202 error goes in there. It could even be an octal memory address and a data value, as was needed for the infamous Apollo 14 hack. There are no legends of what is being displayed, no units, and no decimal points. You have to memorize all of that. But lucky you, there was a cheat sheet of verb and nouns, including values of the data lines, units, and decimal points printed below the telescope optics to refresh your memory if needed. So do you want to keep it in its original vintage form, or do you want to make it work?
What do you guys think? Should we fix it?
I want to fix it.
Wait, stupid question for us. We fix everything. We can't stand it.
All right, we're gonna fix it. And we're gonna keep this display anyway. Right? This might actually power up and light up bits of it.
Yeah, we'll have to check if it's shorted or not.
Yeah.
If it's not shorted, then
Yeah.
And then you said the display, we have the bezel is slightly different. We have to remove or add something.
So yeah, this part of the displays is completely identical to the display that we have, but to provide additional protection for the screen to stop stuff like that from happening, they added an additional shield in front of it, in front of both of these.
We have the shield on
ours,
the
yeah.
extra one.
So as you can see, on this front cover, there isn't any room for the shield. So they milled out these windows a little bit bigger, and then added the shields, which made the shields, but not the modules here, protrude a little bit from the front of the DSKY.
But just looking at the display, the shield looks like to be removable.
It is.
Yeah.
Yeah. We'll have to take off some E-clips.
So maybe this happened and say, oops, we might as well do a shield. It looks suspiciously like what would happen to an iPhone that doesn't have the extra glass protection.
Yeah. So we could try bringing it to one of those guys.
Although this would have been great fun, we decided against bringing our DSKY to the Apple Genius guys for repair. We'll take the repair matters into our own hands.
No, I saw some IDMs. Or at least something in the shape of one.
Ready?
Yeah.
Ooh.
They're green. Look at that.
Indicator driver modules.
As we explained in the 2019 DSKY display episode, we expect the inside of the DSKY to have many relay modules. That's because they did not have transistors that could switch the 250 volts AC necessary to power the electroluminescent segments, nor did they have ICs for memory. So they decided to accomplish both functions using latching relays, which are relays with mechanical memory. As we had shown in the previous episode, they use clever relay logic that requires only 5 relays per digit. That still results in lots and lots of relays. Each Block 2 relay module, called an indicator driver module or IDM, holds 22 relays. Counting the digits, signs, and warning lights, the DSKY needs a little bit over 120 relays, which should be 6 modules. And sure enough, this is mostly what we see here. There is a problem though. One of the modules has a yellow dot, which means it has a defect of some kind.
So we can start on that. And then there's evidence of some scratching that was happening here from previous attempts to get in here. So I think we'll just kind of protect that with a little piece of cloth or paper or something.
Alright, and that's all the screws holding the 2 layers together.
Take a look around. So we're tightening these to push it?
No, loosening. There's a E-clip there that is holding the screw captive.
Oh,
But you only want to go a little bit and then start turning the other one to back it out evenly.
Aha, we have just encountered a jacking screw. These special screws are used to pull halves of assemblies apart when there is a connector joining the two, so there is no risk of tilting the pins. I had to machine a few of these NASA screws when we rebuilt our main connector assembly for the AGC. That's a screw that's easy to damage if you don't realize it's a jacking screw and try to force it out before the other regular screws are removed, which is what had just happened here in the past apparently.
More scratches there.
Oh, we're not the first ones to open it up.
Nope. I don't know how long ago. Oh, it did something.
Is the E-clip coming off?
You're losing your E-clip there.
Oh, it's coming off.
Yeah.
We need to be able to push it back down, I think.
Yeah.
So there's just too much force on it and it's pushing the E-clip out of the groove.
It was already bent from
Yeah.
whenever it was last disassembled, I assume.
Yeah.
Someone probably ripped it out or something.
If you don't know that that's there, you might just like, I'll take out the screw and it.
Oh, they pulled
Kills
out
the
too
E-clip,
far.
yeah.
Yeah, that would definitely do it.
Yeah, I have to imagine that this means that there's a battery relay on that one. A yellow dot next to the part number means that the thing is non-flyable for some reason. But they had so many problems with the relays and well, really throughout the program, not even just in the early ones. Apollo 12, twice I think during the launch countdown, they had a relay short in the DSKY that just caused the EL panel to fully light up and display all 8s.
Oh no.
didn't recur throughout the flight, but just like
They have a little hammer in their toolkit.
yeah.
Bang on it with a glove.
Percussive maintenance.
Yeah, maybe that's why they added the protective glass in front.
Okay, so let's see. That might work. No.
Oh,
Yeah.
looks good.
Cool.
Feels right. All right. Back in business.
Yeah, I see it taking
holding,
the thing
yeah.
apart. Yeah.
Is it coming apart again?
Yeah,
Just
there we go.
separate. Straight.
I'm done.
Alright.
All right.
Lift off.
Ooh,
Wow.
oh. And you have all the good stuff in your hand, right? So that's all the control.
Yep.
Okay.
Looks in good shape to me.
Shielded connection.
Mm-hmm.
What's going on with that?
Isn't it a bad cable?
No. That's
To repair.
looks like a repair to me. I forget if it's this plate or this plate is like one of the only things we don't have a drawing of mechanically in the DSKY. It's one of these two connector plates.
Well, the pins are numbered. That's nice.
Mm-hmm.
Which is that one?
This is the keyboard module. So this has the diode matrix that encodes the key presses into 5 bits.
Okay.
So we put the back parts back together. We took all the front screws off, and now we'll see what's under here.
Wow. I like how each key has its own part number.
Yeah, and you can see the hermetic little
Nice
switch.
that is.
Whoa,
Yeah.
fancy plate.
Those front covers are very pretty.
Oh, hold on. Here you go. Oh yeah, that's a nice one.
And we can also take this off and put it in our test rig and
Yeah,
see what it does by itself.
I am just thinking aloud if there's a short in that thing and we
We can
Put it-
test very short before we put it on.
yeah.
Oh.
Yeah, see how that works?
Oh my goodness.
Those are very expensive micro switches.
Yeah, they look
They're like
expensive.
$700 a piece on DigiKey.
Are those the ones
Mhm.
that are like welded and hermetically sealed?
Yeah.
Mhm.
Ready?
Is it the same thing?
$136.
Can you flip it on its other side? For the camera?
Sure looks like it's the same.
Oh my, it hurts just looking at it.
This one's definitely sticky.
We can fix that. If we undo these set screws, the whole shaft will pull up.
I had to do a little bit of surgery on this button. So it's a two-spring design. There's the big spring for a large travel, and then at the end there's a little spring that goes and pushes the switch. So yeah, it goes easy then hard. So the key is stuck, and it's really this part. Okay.
Moments later.
Okay. This the new keys working.
Yeah, repaired 0 key.
All right. We have to take it entirely apart with springs flying all over. Okay. So these are our 3 screens. A prototype one, a replacement one, and a broken one. And the simplest experiment would be to put the broken one on our setup back there because it's already ready to go, and we checked that there was no shorts, right?
Yep, there's no shorts.
So
At least not to ground.
Although it looks bad, it should be safe to put on the setup. See if it still lights up despite the break. We still had Carl's setup from 2021, which we exhibited on occasion, so we simply plugged our broken screen into it, on the remote chance that it would somehow still light up. Man, if it still works, this is going to be a high reliability test here. Okay, high voltage.
Yeah, very faint.
Oh!
Right,
There's some life. Oh, even have a 1202, even in the right next to the damage.
That's impressive.
Oh, it's flickering in and out.
We need to have a thermal scan on this.
Do you want to repair the DSKY with that one? And then we have to make a contraption to drive the DSKY.
Right.
So it doesn't really matter which screen we have.
And we gotta do something about that connector also.
Yeah. Our favorite Deutsch connector. Well, congratulations, Marcel. We have 3 DSKY displays. One with no cracks, one with a little crack, and one with a big crack.
Testament to the engineering that it works at all. Right?
Yeah, amazing. It's like modern stuff. It's like, the DSKY fell out of somebody's pocket and broke like a modern screen. So not bad after its great fall. Anyhow, you know us, we'll attempt to repair our poor banged up DSKY and make it work like it used to in the next episode. See you then!